Hi friends, welcome to my channel. Today we will learn chemistry, and in chemistry we were doing the physical and chemical changes. In the last video we discussed about what is physical change, example, chemical change, example, and some other facts. And this video, that is physical and chemical change part 2, we will know about the chemical reaction. So let's recap about the last day's work. Physical and chemical change. The change which alters only the physical features of a matter, keeping the chemical composition same, is called the physical change. Example: melting of ice, tearing of paper, etc. Now we have the chemical change. The change which alters the chemical features of matter, making into new substance, is called a chemical change. For example, electrolysis, photosynthesis, etc. So let us know the new topic. Let's start.
What is a chemical reaction? A chemical reaction is a process where substances called reactants are transformed into new substances called products, involving the breaking of existing chemical bonds and the formation of new ones. This transformation results in substances with entirely different chemical properties from the original reactants.
So let us understand what is a chemical reaction. A chemical reaction is a process where substances called reactants are transformed into new substances called products, involving the breaking of existing chemicals bonds and forming of new ones. So let us highlight the points. I would first try to understand that we have substances called reactants. To understand the reactants, that the substances which are reacting in the chemical reaction is called the reactants, and the new substances that is formed, that is the final substances that is formed, is the products. And what does it happens during a chemical reaction? That involve a breaking of existing chemical bonds and the formation of new ones. Suppose we have this like these two bonds, and this is broken down to this and this. So this is how chemical reaction occurs. Also, this transformation results in substances with entirely different chemical properties from the original reactants. So let us understand some of the examples of the chemical reaction.
Examples include the burning of wood, the rusting of iron, and the reactions that occur in your body to digest food.
Exactly. When we are burning of wood, then the wood is burnt, which gives out light and heat and some gases like carbon dioxide and all those. Also, at the result, some ashes are formed which are not equal to the wood. When iron is rusted, it becomes weak and reddish in color with a different chemical composition. And also, when HCl, that is hydrochloric acid, inside the stomach helps in digestion and helps to get rid of the germs. It is also a chemical reaction. Now let us know what is the chemical equation.
Chemical equation. The symbolic representation of a chemical reaction in a short, simple way is called chemical equation.
So, a chemical equation is a symbolic representation of the chemical reaction in a short, simple way of the chemical reaction. So, if I am saying that one molecule of Yes, and yes, if we mix one molecule of zinc and one molecule of sulfuric acid, then it will form one molecule of zinc sulfide and one molecule of hydrogen gas. But if I say this, it will be very long and difficult to be understood by other languages people. But if we write in this format that is given below, like Zn plus H2SO4 gives us ZnSO4 plus H2. This is the chemical equation, and as Zn is the zinc, H2SO4 is the sulfuric acid, ZnSO4 is the zinc sulfate, and H2 is the hydrogen gas. So let us know about the components of the chemical equation.
Components of a chemical equation. Reactants, the substances which is where, on which, the chemical reaction happens is called reactants. It is generally put in the left-hand side of the reaction.
Now, if we see in this reaction that we know that Zn plus H2SO4, these are the main two components that are used in the reaction. So, this is called the reactants. Also, if we write that reactants, then we get a term react. That means they are reacting, and they are the main component that we are using at the beginning to make the chemical reaction. So let us see what are products. And also reactants are most of the time put in the left hand side, that is the LHS of the equation.
Products. The substance which is produced in the reaction is called as the product. It is generally put in the right hand side of the reaction.
Now, the substances which are produced is the product. Also, if we see that prod and this prod of the produced, the prod of the produced and the prod of the reaction is same. So from here we can remember that the product is the substances which is produced in the reaction. Also, when we are multiplying like 2 into 2 equals to 4 in mathematics, this is the product. That product means that the answer which is got after the equals to sign, and if we think this arrow has equals to sign, then 4 will be the product, and like this we can remember in real life. So let us see at the example.
Example. Zn plus H, so ZnSO plus H. Zinc plus sulfuric acid, zinc sulfate plus hydrogen. Reactants product.
Yes. Now this side is the reactant as I told, and this side is the product. And this is the arrow that shows that where is the reaction going. If it is this, that means this side is the reactant, this side is the product, and if it is like this side is the product and this side is the reactant. It shows that which is the reactant and the product and how it goes. Zinc is sulfuric acid, H2SO4 is Zn is zinc, H2SO4 is sulfuric acid, ZnSO4 is zinc sulfide, and H2 is hydrogen. So let us move forward.
Information conveyed by chemical equation. The formula, symbol, names and physical states of the reactants and products. The relative number of atoms and molecules of the reactants that take part in the reaction. The relative number of atoms and molecules of the products formed in the reaction. The ratio of the masses of the reactants and products. The ratio of the volumes of the gaseous reactants and products under the same conditions of temperature and pressure. The total mass of the reactants must be equal to the total mass of the products formed. The total No of atoms of the reactant S must be equal to the total No of atoms of the product S. But the total No of molecules and the reactant S may or may not be equal to the product S.
So let us understand each point separately and carefully. So at first we have the formula and the symbol names and the physical state of the reactants and products are known from here. If we see upward, in a zinc, if we write Zn plus H2SO4 gives us as Zn-SO4 plus H2. From here we know the zinc, the formula of zinc, the formula of sulfuric acid, the formula of zinc sulfate, the formula of hydrogen gas, the and other elements like Zn, H, SO4, S, O, and all those. We are knowing a lot of things from the chemical equation. But if we write only zinc, if we write zinc plus sulfuric acid, or if we write something easy like water gives out a hydrogen plus oxygen. Did we understand anything from it? Yes, we understand that when water is broken down, it gives us hydrogen and oxygen. But how much molecule of water will give us how much hydrogen and how much oxygen? No. What is the formula of water? No. What is the formula of hydrogen? No. What is the formula of oxygen? No. At which temperature it is formed? No. What are the necessary requirements? No. Nothing. Just water gives out hydrogen plus oxygen. This is not enough, and that is one of the most important advantage of the chemical equation. Now next is that the relative number of atoms and the molecules of the reactants that take part in the reaction. For example, if you take an easier example of water, like that, if we put H2O gives out H2 plus O2. Here, if we balance the equation, that will be discussed later in the next session, that after balancing it, we will find out that yes, after balancing we got this, that 2H2O gives out 2H2 plus O2. That means 2 molecule of water when decomposed gives out 2 molecule of hydrogen gas and 1 molecule of oxygen gas. Here the number of molecules that is in the reactants can be known. The relative number of atoms and molecules of the products are formed in the reaction. That I told that the reactant and the product both are known from here. Yes, now the ratio of the masses of the products. Like here, we have got two molecules of water gives out 2:1. if we see that if we make hydrogen is to oxygen, then it will be 2 is to 1. The products will be 2 is to 1. And if we see the molecular form of the water, then the composition will be also 2 is to 1. It is also a great advantage of the chemical equation. Now let us see the next point. The ratio of the volume of the gases is reactants, gaseous reactants and products under the same condition and the temperature and pressure. For example, when gases are mixing or making some chemical formula or chemical reaction, then that condition, temperature, pressure, everything is known by it. Next we have the total mass of the reactants must be equal to the total mass of the products formed. If we see the mass, then the 2H2O will be equal to 2H2 plus O2. And the last point states that the total number of atoms on the reactant must be equal to the total number of atoms of the products. It is a very important topic, and that is how we do valency, like that balance of the equation. But the total number of molecules and the reactants may or may not be equal to the products. Like if we see that 2H2O plus this space is if we write here that 2H2O gives out 2H2 plus O2, then if we count that there are two, and here if we saw something, then it will be into or multiplied with the each and every element. 2H2, that means 4H, that is 2H2 is here. 2O, that is O2, that means the molecules will be not same, may or may not be same, but the number of atoms will be always same. Here is 4 hydrogen, here is 4 hydrogen, here is 2 oxygen, here is 2 oxygen, like this. Now let us see at the advantages of the chemical equation.
Advantages of chemical equation. The representation of actual chemical reaction becomes easy by using equation. It saves time and space in writing. To prepare a known amount of the product, we can calculate the amount of the reactant to be taken. The chemical equation can be understood by the chemists belonging to any country of the world irrespective of the language they speak.
These are already the information that is we can say it is a great advantage. A great advantage of the chemical equation, but also there are some normal advantages that we will learn now. The representation of the actual chemical equation chemical reaction becomes easy by the equation. It saves time and space in writing, that I told you before. To prepare a known amount of product, we can calculate the amount of reactant to be taken. For example, in some types of reactions, like in the reaction given above, that is Zn plus H2SO4 gives out ZnSO4 plus H2. It is a certain type of reaction and is called the it's a certain type of reaction that we will understand in the next session. If we say that zinc went to SO4, that is ZnSO4, and H2 who, as there is nothing there, and it evaporated and became as the separate product. And this type of reaction is called the displacement reaction. And this is the actual name is the single displacement reaction. We will talk about it in the next session. The chemical equation can be understood by the chemist belonging to any country of the world, irrespective of the language used. If we say Zn, in English we may call it zinc, or in other but in other languages there might be other names like copper, Cu. It is one of the most common metal that we use. So various languages have various names, but if we write Cu, then every chemist and every people who know that and who know chemistry can understand that Cu means copper. And in English, but in English if we say copper, then other chemists might not know it fully or take a lot of time to understand it with lot of studies. So the chemical equation can be understood by the chemists belonging to any country of the world, irrespective of the language they speak. Also, we know that the thing that is an advantage also has a disadvantage. So now we are going to know about the limitations of the chemical equation. Let's start.
Limitations of chemical equation. Conditions of pressure and temperature of the reaction are not known. Supply of heat, electricity is not known during the reaction. Whether any catalyst is used or not cannot be known from the equation. The equation does not tell about the physical states of the reactants and product, i.e., whether these are in solid, liquid, or in gaseous state is not revealed. Concentration of liquid reactants and products, like acid, alkali, is not known. Reversibility of reaction, i.e., whether the products recombine to form the original substance, is not known. A chemical equation does not tell us about the rate of the reaction and the time taken for the completion of the reaction. Extra advantages of modern.
Yes. Now let us understand the limitations of the chemical equation. At first, we have the condition of the pressure and the temperature of the reaction not known. On how, at which temperature, at which pressure, the chemical reaction will occur, it is not known by the chemical equation. Supply of heat, electricity, or sunlight is not known from the equation. A catalyst. Do you know what is the meaning of catalyst? Let us know. A catalyst is something that helps to fast enough. That is to make a reaction fast. To slow down or make a reaction fast. It has to slow down or make a reaction fast, a catalyst. But whether the catalyst is used or not, it is not known. The equation does not deny the physical state of the reactants and products, that is whether they are solid, liquid, or gas. That is not revealed. Like from the above reaction, can you understand that zinc is solid or liquid or gas? A sulfuric acid is solid, liquid, or gas? ZnH4 is solid, liquid, or gas? Or hydrogen is solid, liquid, or gas? No, we cannot understand from it. The concentration of the liquids and products like acid alkali is not known. We don't know that at when as is in H2O, that is water, is made into H2 and O2. And is that water acidic, or it has alkali property or base property? No, we don't know it. The reversibility of the reaction. The reactions that is shown on some time above, is that reversible? Like, can ZnSO4 plus H2 can react it to form Zn plus H2SO4? That is not known. A chemical equation does not tell us the rate of the reaction and the time taken of the completion of the reaction. How much time will take? 1 hour, 2 hour, 2 minutes, 1 minute, 1 second, 2 seconds. It is not known. Now, to avoid some of these limitations, there are modern chemical equation, like we have made some changes in the chemical equation to understand and to avoid some of the limitations, which we are going to know now.
Chemical products. The substance which is
Sorry.
Example. Zn plus H, so ZnSO plus H. Advantages of modern chemical equation. S, 1, or G may be written respectively for solid, liquid and gaseous reactants and products. For exothermic reaction, -H, and for endothermic reaction, +H, may be written. Temperature, pressure and the catalyst used may be written on the arrow of the arrowhead equation. The sign is used for reversible chemical reaction. Give an example.
Now let us understand some of the extra advantages of the modern chemical equation. Like, the hydrogen evolved from the equation earlier, and behind that we might give the sign as G. If we give as G, then we will understand that that it is in the gaseous state. Right. With H2O, we can give as L. It is L, not 1. With a zinc, we could give as S. That means it's solid. For exothermic reaction, minus delta H, and for endothermic reaction plus delta H might be written. And this sign is a Greek letter known as delta, which means change. And do you know what is exothermic and endothermic reaction? Let me tell. Exothermic reaction is a type of reaction where the heat is rapidly released. Like exo. What do you mean by the word exo? Exo means external. If we say external, exo, it might sound familiar or similar. So from that exothermic, that it will give out heat. It will give out heat to external. That is, it will release heat. In that case, minus delta H. It means that the heat is removed from the reaction and it is given out, which makes it hot. And plus OH, that means endothermic reaction, which is fully opposite. which means that at plus delta T, which means that the reaction is taking the heat from outside. If there is a glass tube and there is a reaction going on inside, and that is an endothermic reaction, then it will take the heat from the glass tube and make it colder. And then as the compound or the element or the reaction is gaining heat extra, it will be the endothermic reaction. Temperature, pressure, and catalyst used by the arrow written on the arrowhead equation. Like if we write here the catalyst or something, or 400, suppose 200 atm, I am writing atm is a unit of pressure, that is atmospheric pressure. If we say that it is a unit of pressure, that means it is 200 atmospheric pressure. Like we have 1 atmospheric pressure above us and 200, so lot. It is written on the arrowhead. Or pressure written temperature 200 degrees Celsius. Or catalyst, or which catalyst is used, HCl. For the in very few reaction HCl is used, and HCl can be rated as the catalyst of the arrowhead of the equation. And this sign is used for the reversibility of the chemical reaction. Due to some issue, the sign is not given, but I am giving a sign. That is, this sign is written. If we write, wait, let me write it clearly for you to understand. If we write 2H2O, if so, H2O gives out 2H2NO2. Here, this sign means that it can be this and also big. This is going here, and also this sign means that it is reversible. I hope everyone understood, and this is the end of the today's lecture. But now we have some practice sheet of part 1 and part 2. As the part 1 was very small, that's why we combined the practice sheet of part 1 and part 2. This will be everybody's homework. But let us just discuss what might be the answers.
Example of irreversible physical change.
An example of irreversible physical change, like the physical change which is not reversible, we cannot reverse it.
State 5 examples of chemical changes.
Chemical changes we know.
What is a chemical
and we will give 5 examples.
equation?
What is the chemical equation? It is today.
What happens when a candle is burned? Chemical change. Physical change. Both A and B. None of the above.
It is an MCQ type question. You have to understand.
How some limitations of chemical equation be avoided? State any 2 ways.
This question is understood today, but it might be confusing for you that limitations of equation that is avoided, how we will write. So I am just telling what to write. Here, that extra advantage of the modern chemical equation, the answer is from here. You will write any 2 points from here. And thank you guys. I hope you had a great time learning chemistry, and in the next lecture we will learn how to balance an equation. What are the types of chemical reactions? So just send this into my email. That is utsavk18190111@gmail.com. I hope you had a great time. Just pause the video and answer the questions and quickly send me to the email ID given here. Thank you. I hope that you had a great session. Bye. We will meet in the next session. I hope you will be safe and don't leave chemistry and keep studying. Thank you.